The deep ocean is one of the most dangerous places on Earth, and submarines are built to withstand extreme pressure. But what happens if a submarine suddenly implodes? Could anyone survive such a disaster? Or would the crushing force of the water make survival impossible? In this video, we'll break down the science of submarine implosions, what causes them, and whether there's any chance of making it out alive. Make sure you subscribe to our channel and press the bell icon to get regular updates. Let's dive in. Understanding the reality of a submarine implosion. A submarine implosion is one of the most catastrophic disasters that can happen underwater. Unlike other types of marine accidents, such as engine failures or fires, an implosion occurs suddenly and with immense force, leaving no time for response or survival. The ocean is an unforgiving environment, and as submarines descend to greater depths, they are subjected to intense water pressure. Every vessel has a depth limit, known as the crush depth, which is the maximum point it can withstand before the surrounding pressure becomes too strong. The deeper a submarine goes, the more stress it experiences. If the hull is weakened by structural flaws, external damage, or exceeding its maximum depth limit, it can collapse inward almost instantly. The terrifying part is that an implosion happens in milliseconds, meaning that no one on board has time to react, let alone escape. Some might wonder whether survival is possible in such an event, but unfortunately, the extreme forces involved make it nearly impossible. The sheer speed and violence of an implosion mean that even the best trained crew members or the most advanced safety systems wouldn't stand a chance. The science behind an implosion. To truly understand why survival is impossible, we need to look at the physics behind an implosion. A submarine is built to handle immense external pressure using a strong, reinforced hull. Most modern submarines are made of high-strength steel, titanium, or composite materials, designed to withstand incredible forces. However, no material is completely invincible. As a submarine dives deeper, the surrounding pressure increases dramatically, and if the hull reaches its breaking point, it collapses inward in an instant. Unlike an explosion, which pushes force outward, an implosion pulls everything inward with crushing intensity. This means that instead of being torn apart, a submarine is squeezed into itself. The air inside the vessel compresses rapidly, generating an intense heat spike that can briefly reach thousands of degrees. Essentially, everything inside is vaporized almost instantly. The human body wouldn't have time to feel pain or fear. The entire event would be over before the brain could even process what was happening. Because water pressure moves at supersonic speeds in an implosion, the collapse of the submarine is nearly as fast as the speed of sound in water. This means that from the moment the hull gives way, the entire vessel is destroyed in a fraction of a second. There is no gradual process or warning, just instant destruction. This is why, despite movies or fictional accounts that suggest people could survive in air pockets or make a last-minute escape, the reality is that no one inside a submarine that implodes could make it out alive. The depth factor, how pressure increases with depth. One of the biggest factors in an implosion is depth. The deeper a submarine goes, the more extreme the pressure becomes. At the ocean's surface, the pressure is about 14.7 pounds per square inch, PSI, which is the normal atmospheric pressure we experience on land. However, for every 33 feet, 10 meters, a submarine descends, the pressure increases by another 14.7 pounds per square inch. This adds up quickly. At 1,000 feet, about 300 meters, the pressure is already around 445 pounds per square inch. By 3,000 feet, it is a crushing 1,350 psi. If a submarine were to reach 10,000 feet, over 3,000 meters, the pressure would be an almost unimaginable 4,450 pounds per square inch, enough to crush steel like a soda can. To put this into perspective, this level of pressure is so intense that it could flatten a car instantly. Even submarines designed for deep-sea exploration have strict depth limits. If they go too deep or suffer even a small structural failure, the results are catastrophic. A human body completely unprotected would be crushed to the size of a basketball under such pressure. This is why even if someone were outside the submarine in a specialized diving suit, survival beyond certain depths would still be impossible. Can a submarine partially implode? Some might wonder whether a submarine could experience only a partial implosion, leaving some sections intact and allowing survivors to escape. Unfortunately, this is not how implosions work. When a submarine's hull fails at extreme depths, the collapse occurs at a speed too fast for containment. The instant one part of the submarine gives way, the entire structure follows. In some rare cases, if a submarine is at a shallower depth and suffers damage, there might be time for emergency measures. However, in deep-sea conditions, even the smallest breach is enough to trigger a total implosion. The pressure rushes in with such force that the entire vessel is destroyed before anyone can even register what is happening. This is why deep-sea implosions leave behind very little wreckage. Most of the submarine is crushed and shattered into tiny fragments. A common question people ask is whether someone could escape from a submarine before an implosion happens. In theory, if a submarine were at a shallow depth and warning signs were detected early, crew members might have time to use emergency escape pods or specialized diving suits. However, in deep-sea implosions, this is simply not possible. First, an implosion happens too quickly. By the time a structural failure is detected, the submarine is already collapsing. Second, even if someone had access to an escape hatch, the change in pressure would be deadly. A rapid ascent from deep waters can cause severe decompression sickness, also known as the bends. This happens when nitrogen gas, which is dissolved in the body under pressure, expands too quickly, leading to excruciating pain, paralysis, or even death. Real-life examples of submarine implosions. Throughout history, several tragic submarine implosions have occurred, reinforcing the harsh reality of deep-sea disasters. One of the most well-known cases is the loss of the USS Thresher, SSN 593, in 1963. The submarine was conducting deep diving tests when it suffered a mechanical failure, likely leading to an implosion. The wreckage was later found scattered across the ocean floor, confirming that the vessel had collapsed under immense pressure. Another infamous case is the K-129, a Soviet submarine that disappeared in 1968. Though much of the information remains classified, experts believe that a catastrophic hull failure led to a rapid implosion. Similarly, the Titan submersible, which was exploring the Titanic wreck in 2023, suffered a structural failure that caused an instant implosion. The extreme depth and pressure meant that those on board had no chance of survival. While the idea of a submarine implosion is terrifying, the only small mercy is that it would be over instantly. Unlike other maritime disasters, where crew members might struggle to escape or face a slow, painful demise, an implosion occurs so fast that the brain doesn't even have time to process it. However, the moments leading up to an implosion could be incredibly distressing. If the crew were aware of mechanical failures or warning signs, they would likely experience intense fear and anxiety. Knowing that escape is impossible and that death is inevitable would be an unimaginably terrifying experience. Could future technology prevent implosions? As technology advances, engineers are constantly looking for ways to make submarines safer. Some researchers are exploring the use of carbon fiber composites and self-repairing materials that could withstand higher pressures. Others are working on advanced monitoring systems that could detect structural weaknesses before they become critical. While these innovations could help reduce the risk of implosions, the laws of physics remain unchanged. Unless there is a breakthrough in materials science that allows for completely pressure-proof submarines, the risk of implosion will always be present in deep-sea exploration. What do you think? Could we ever develop a submarine that's completely resistant to implosions? Let us know in the comments. And if you found this video interesting, don't forget to like and subscribe for more deep dive explorations. Thanks for watching till the end.